There was supposed to be a beginning. For nearly a century, we told the story with confidence. The universe, we said, started in a single, unimaginably dense point, a singularity, zero size, infinite density, infinite temperature, space compressed into nothing, time compressed into nothing, and then an explosion, expansion, the birth of everything, the Big Bang. It became more than a theory, it became a cultural origin myth, backed by equations, supported by cosmic microwave background radiation confirmed by galaxy expansion. It felt complete, but physics has a dangerous habit of turning certainty into scaffolding. Because the deeper we push into the mathematics of the early universe, the more that beginning starts to dissolve, not disproven, deleted. And recently, something strange has happened. New theoretical frameworks, new cosmological models, and subtle observational clues are pointing toward a possibility that would have seemed absurd decades ago. The universe may not have had a beginning at all. To understand why this is even on the table, we need to revisit the singularity. The singularity was never a physical object. It was a mathematical warning sign. When Einstein's equations of general relativity are run backward in time, the universe shrinks. Galaxies collapse toward one another, density increases, temperature skyrockets, and eventually the equations break. They spit out infinity. Infinity is not a measurement. It is a signal that the theory has reached its limit. When general relativity predicts infinite density, it is not telling us reality contains infinity. It is telling us the theory is incomplete. For decades, we accepted that incompleteness as inevitable. The singularity marked the edge of time. Beyond it, we said physics stops. But that answer was always uncomfortable, because singularities are places where predictability dies, and physics is, at its core, the art of prediction. So theorists began asking a forbidden question. What if the singularity is not a beginning, but a misunderstanding? Enter quantum gravity. General relativity describes gravity as the curvature of space-time. Quantum mechanics describes reality in terms of probabilities and wave functions. For most of cosmic history, these two frameworks operate separately, but near the supposed beginning of the universe, they must collide. At extremely small scales, Planck scales, space-time is no longer smooth. Quantum fluctuations dominate. The geometry of space-time itself begins to jitter. And when physicists attempt to combine relativity with quantum principles, something remarkable happens. The singularity disappears. In several candidate theories of quantum gravity, loop quantum cosmology, certain string-inspired models, and even some semi-classical corrections, the universe does not compress to a point of infinite density. Instead, it reaches a maximum density and rebounds, a bounce. The equations no longer scream infinity. They describe a transition. Instead of a beginning, there is a bridge. Imagine running a cosmic film backward. Galaxies contract. Stars dissolve into plasma. Plasma compresses into an ultra-dense state. But instead of collapsing into a singular point, quantum effects push back. Gravity becomes repulsive at extreme densities. The contraction halts, and then the universe expands again, not from nothing, from something before. In these models, the Big Bang is not the birth of the universe. It is a phase transition, a turning point, which raises a terrifying possibility. What if our universe is just the latest expansion cycle in an eternal sequence? This is not science fiction, it is mathematics. Loop quantum cosmology, for example, modifies the Friedmann equations, the equations governing cosmic expansion, by incorporating discrete quantum geometry. The result is a maximum critical density. When reached, gravity becomes effectively repulsive. The singularity is replaced by a bounce, no beginning, just a previous contracting universe. But theory alone is not evidence. The real shock came when cosmologists began examining subtle anomalies in the cosmic microwave background, the afterglow of the early universe. The CMB is often described as a snapshot of the universe 380,000 years after the Big Bang. It is remarkably uniform, but not perfectly. Tiny fluctuations, 1 part in 100,000, encode the seeds of galaxies. For decades, the standard inflationary model explained these fluctuations beautifully. Inflation, a rapid exponential expansion in the first fraction of a second, smoothed out the universe and stretched quantum fluctuations to cosmic scales. But inflation has its own problem. When pushed to its logical limits, inflation tends to be eternal. It spawns an infinite multiverse of bubble universes. It does not eliminate the need for a beginning. It merely shifts the problem backward. And more importantly, certain large-scale anomalies in the CMB, unexpected alignments, suppressed fluctuations at the largest scales, have prompted speculation that something preceded inflation. Some researchers have suggested that traces of a pre-bounce universe could survive the transition, imprinted subtly in these patterns. The data is not conclusive. It is subtle, but it is enough to keep the question alive. Meanwhile, another approach has emerged: conformal cyclic cosmology. Proposed by Roger Penrose, this model suggests something even stranger. In Penrose's view, the universe does not bounce in a violent contraction-expansion cycle. Instead, it fades. As the universe ages, stars burn out. Black holes dominate. Eventually, even black holes evaporate through Hawking radiation. Matter decays. The universe becomes a thin soup of radiation. In such a state where there are no massive particles left, scale loses meaning. Without mass, there is no preferred measure of size. The universe becomes conformally invariant. And in that extreme future, trillions upon trillions of years from now, Penrose argues that the universe can be mathematically reinterpreted as the beginning of a new Big Bang. The infinitely expanded future of one universe becomes the birth of the next. Not a cycle of collapse and explosion, a cycle of transformation. If this is correct, then the beginning was not deleted. It was redefined. Our Big Bang was the remote future of another cosmic epoch. The universe did not start, it transitioned. But perhaps the most radical challenge to the beginning comes from something simpler: the nature of time itself. Earlier, we discussed the block universe, the idea that past, present, and future coexist in spacetime. If that picture is correct, then asking what happened before the beginning may be like asking what is north of the North Pole. Time may not extend beyond the Big Bang because time itself is part of the structure that emerged there. But some quantum cosmology models suggest time does not behave the way we think at extreme energies. Near Planck scales, the distinction between space and time may blur. The metric signature of spacetime, the mathematical structure distinguishing time from space, may undergo a transition. In certain formulations of the Hartley-Hawking no-boundary proposal, the universe does not begin with a sharp temporal edge. Instead, time gradually emerges from a purely spatial geometry. Like the South Pole on Earth, the beginning is not a boundary, it is a smooth cap. There is no before in the conventional sense because time itself morphs into space. In that framework, the universe did not erupt from nothing. It simply exists as a finite but unbounded geometry. No singular start, no deletion, just a structure without edges. But why does this matter? Why obsess over whether the universe had a beginning? Because beginnings imply causes. If the universe began, what caused it? What mechanism triggered it? Was there something outside it? But if the universe did not begin, if it is eternal in some form, then those questions dissolve. There's no external cause, no external trigger. The universe is self-contained. That idea unsettles people for different reasons. Some prefer a beginning because it feels cleaner. Others prefer eternity because it avoids metaphysical mysteries. Physics, however, is not concerned with comfort. It follows equations. And increasingly, the equations are resisting the notion of a singular start. The evidence is not a smoking gun. There is no cosmic billboard declaring no beginning. Instead, there is a convergence of hints. Singularities replaced by quantum bounces. Inflation pointing toward pre-inflationary phases. CMB anomalies that refuse to fit perfectly. Models where time emerges gradually rather than snapping into existence. Each piece alone is inconclusive. Together, they erode the certainty of a beginning. If the universe deleted its beginning, it did so not by hiding it, but by revealing that our concept of beginning was flawed. Perhaps the deeper truth is this: the universe is not a story with a first page. It is a structure, a geometry, a reality that does not require an origin in the way narratives do. We crave beginnings because we think in terms of sequences. We are creatures of cause and effect. But space-time, at its deepest level, may not obey that storytelling instinct. The Big Bang may not have been the start of everything. It may have been the start of this chapter, or the middle of a larger cycle, or the smooth emergence of time from something more primitive, And if that is true, then the universe did not explode into existence. It always was, in one form or another. The evidence is not final. Cosmology is still young, but for the first time in history, we have mathematical frameworks and observational clues that make an eternal universe not just philosophy, but physics, which leaves us with a final, humbling thought. If there was no beginning, then the question, why is there something rather than nothing, may be misguided. Perhaps nothing was never an option. Perhaps existence is the default. The universe did not need to be created. It needed only to transform. And somewhere, encoded in the faint microwave glow of ancient radiation, in the quantum structure of space-time, in the geometry of expanding space, we may already be seeing the fingerprints of what came before the so-called beginning. Not erased, not hidden, just misunderstood. The universe did not start. It shifted, and we are only now beginning to understand what that means.